The D'Arsonval meter has an internal resistance of 1 kilo ohms, and it requires 10 milliampere for full scale deflection. So we need to be able to measure 50 volt with this meter. So what is the multiplier, the external resistance or the resistance that needs to be added? So basically this is the meter here, which has, let's call it meter, and which the resistance is 1 kilo ohms, and the multiplier that's needed for to increase the range basically of the voltage measure of the measured voltage. So we need to find sorry, this one is the resistance that we need to find, which is R, and this is 1 kilo ohms, and the current is 10 milliamps for full scale deflection. So we need to be able to measure 50 volts here. So what is the value of this resistance that we need to add here? The meter the meter needs adding to increase the range. So basically if I call this resistance as, let's say, X, and the meter resistance is Rm, so V is Rx plus Rm, and the I is, so Rx we don't know, Rm is 1, and current is 10 milliamps, so 10 into 10 to the power minus 3. So V is 50, so Rx will be 50 over 10 times 10 to the power minus 3 minus 1. So we need to write this in terms of kilo ohms, so I am writing 1000 here. So this is 5000 minus 1000, so this is 4000. So this is the resistance that needs to be added, or 4 kilo ohms. So this is the resistance here needed to be 4 kilo ohms. So we can see this way we can increase the range of the voltage that can be measured. Though the current through the meter is going the same, and the voltage drop across it is the same, but the overall voltage that is can be measured by adding this resistance is increased now. And as if we wanted a higher range, like if it were like 100 volts, then we would end up having a larger resistance, and we can calculate the required resistance this way. Whatever range we need, we can add a required multiplier like that. And this is how in a D'Arsonval meter the range can be increased by adding higher value of series resistance.